All right, so today 6.3 is slope-intercept form of a line. So we're going to talk about a couple different versions or ways we can look at equations. So we're still talking linear equations. Our objectives are to write a linear equation in slope-intercept form. Once we learn what that is. 2, identify the slope and the y-intercept of a linear equation. And 3, to graph linear equations from that slope-intercept form. Okay, so first step is the slope-intercept form and what that is. So what is the slope-intercept form?
The slope-intercept form is finding like the point where they meet.
Right, but what is the slope-intercept form? Look at your notes.
Y equals mx plus b.
There you go. Y equals mx plus b is the slope-intercept form. Okay, so that right there is what we're talking about. Your equation has to be in this form when we talk about slope-intercept form.
Are we gonna do like the thing where we have like, say we have like the variables for like b and y, but we don't have m or x?
Yep. Well, you wouldn't have b and y, and you'd have y and x and b, or you'd have some of the others.
Y, m, or b.
I'm
Yeah.
about missing 2 because then you have to like substitute.
Yep.
M for like
Mhm.
x.
We did this last year, didn't we?
Yeah, I was miserable.
Perfect.
I remember this.
Okay, so m, like always, m always stands for the slope. Okay, m is always in front of your x. You should always write it in that correct format. B, okay, is the y coordinate of the y-intercept. So we've got it there. It's 0, comma b is your y-intercept. It's always where it's going to cross your y-axis. You can graph an equation if it is in slope-intercept form. You can pick out the slope and the y-intercept, you graph the y-intercept, and then use the slope to graph more points. It's super simple once we get it in slope-intercept form. Okay, so let's look at that, the steps. So using slope-intercept to graph. Step 1, we have to write the equation in slope-intercept form. So we have to get it in the y equals mx plus b form. Look at that, we're ahead of schedule again today. Okay, 2, we plot the y-intercept, so that's 0, comma b. 3, we're going to use the slope to plot several more points. And then 4, we draw a line through the points. But number 1 is the kicker. It's getting it in the slope-intercept form. Because you all have, some of you have struggled with showing your work and different things. This is where I see the biggest hiccup for you, is like writing it in the correct form. Okay, so let's try example 1. Because I know you all can do it. It's just keeping your work organized, which is so very important. All right, so example 1. Write 3x plus 2y equals 6 in slope-intercept form. Then state the slope and the y-intercept. So step 1 is the same here. It says it's written differently. Solve the linear equation for y. We've got to get it in this form. Y equals mx plus b. So we've got 3x plus 2y equals 6. We need to solve for y. What do we need to do first? Okay, that's what I said, but what do we need to do first in order to get y by itself? We cannot divide by 2.
Do minus 2y.
We can't minus 2y. Because then if we can subtract 2y, but then we're going to have to move the 6. It would be more work. The easier thing would be to move this term to the other side first. So subtract the 3x, because it'll move it to the right side, remember, of our equation. So then we're left with 2y equals what? 6 minus 3x is not going to get a slope-intercept form. Right? That's the thing. It has to be mx plus b. No, no. Because the x... Time out. These are the numbers, but instead of putting, like typically in the past, we have written 6 minus 3x. But if we compare that to this, we have to have the x, the number...
3x plus 6?
Yes, we have to have the x come first. So it would just be negative 3x plus 6, because it's a positive 6. Again, that's why we've talked about minus and negative are similar. plus and positive numbers are similar. Okay, if it's a positive number, we can add it. All right. Now, we still need to get y by itself.
We wanna not divide. Yeah, divide.
Because all we have left is 2y. 2 times y. So we're going to divide by
2.
divide by 2. So 2y divided by 2, right? The 2's cancel, and we're left with y. On the other side, sometimes there's some confusion there. Each part of this is being divided by 2. So what's negative 3 divided by 2? Negative 3 over 2, because remember, we would rather have slope as a fraction than a decimal, because it's rise over run. So we leave it as a fraction. So negative 3 over 2x, and then what's 6 divided by 2? 3. So it's a positive 3, so plus 3. That is slope-intercept, right? If we think y equals mx plus b, we have it in the right form. So we've already done step 2, arranging them in the correct order. Nope, we don't need to find x. We don't need to find y. Nothing. We are kind of done because it says to state the slope, which is m, and the y-intercept, which is b. So, Bailey DeFries, what's the slope here?
Negative 3 over 2.
Perfect, right? The slope is right there. Negative 3 over 2. And Cheyenne, what's the b? What is the b value, right? 3. That is it.
That's not as hard as I remember it being.
Okay. Now, if I had to take this one step further, let me draw us a graph if I have to take it one step further. Let me erase a little bit here, actually. So, all right, we're going to get to this, but I want to show you, go ahead and show you now how this would look. So if my y-intercept is 3, I'm going to go to 3 on my y-axis, 0, 3. I'm going to put a point there. And then I'm going to use my slope, negative 3 over 2. So I'm going to go down 3, 1, 2, 3, and I go right positive 2. Down 3, 1, 2, 3, and right 2. And I just graphed it. Okay, I can graph it once I get it in slope-intercept. And again, you don't have to do that on your paper. We're going to practice it, but I wanted you to say like that's the last and final step of the whole thing. So let's flip over and see what else we have. Hey, look, it's graphing.
I do not like graphing.
Okay, so let's look at the equation. Is it in slope-intercept form? Slope-intercept form is y equals?
Yes, it's in slope-intercept form.
Okay, mx plus b. It's in slope-intercept form. So all we have to do is find the slope. What's the slope?
1/2.
1/2. Abigail, what's the y-intercept? What's the y-intercept? 4. Okay. All right. And now we're ready to graph.
I'm ready.
All right. Where would we? Okay. Where would we graph? Cameron, go up and put our first point. Where is our y-intercept on this graph?
Wouldn't it be?
That's an x-axis, not your y-axis.
M is 1/2, right?
Perfect. Go ahead and make it a little bolder. Good. So the y-intercept is always on your y-axis. Great. All right.
I literally don't understand how you got that.
So, you know how you
Because the y-intercept is 4.
mx plus b and
Wait, is this continuing on this one?
No, this is a different problem. It's a different equation.
It's on the back.
it's y is
Okay.
1/2 x.
Hold on. Let's see. Olivia, can you go up and graph another point using our slope? All right, so because this equation is written in the same format, the y equals mx plus our b. So our m value is 1/2. The b value is 4. B stands for the y-intercept, where the graph intersects, the y-axis is up 4. 1, 2, 3, 4.
Where's this one gonna be? Like
So
right
slope,
here?
nope, slope is 1/2. So remember that's rise over 1. So we go up 1 and over 2. Okay, good. Josie, can you give me another point on the graph? Yeah, there's more.
I can do more. So this would be M.
Nope, that's not 1/2. We have to go up 1 over 2. So here's a point. So this is not
Oh,
1.
from this.
From this.
I got it.
You remember now? We talked about it a little bit in the past.
So
Oh, not there. Nope.
It moved.
So remember.
I put it in the right spot. It's wrong.
Okay. You got to go back to the pencil. Did you get the pencil? Nope.
It's the next one then. It's okay. So it's.
Nope. Okay, so what was the deal?
I have no idea what you're talking about with the third dot. Like.
Okay, that's good. That's what I need to do. Well, that time you got it in the right place.
Yep, because I guessed.
Because you guessed. Okay.
That's on the other paper too.
All right. So if you remember last week when we talked about this, we can go 1 over 2. Okay, means up 1, right 2. The opposite is if we had negative 1 over negative 2, because negative divided by negative is still positive, right? But in this case, it would mean down 1 and left 2, which is what we did here. We went down 1 and left 2. We could go down 1 and left 2 again. And then we would have several points on our line. Because it should make a straight line. If you have a graph that doesn't make a straight line, you've done something wrong.
So what? Like, how do you get that negative one?
Because it's equivalent to 1/2. You can use a positive 1 over 2 equals 1/2. A negative 1 over negative 2 equals 1/2.
And that's it, right?
And that's it, yeah. We also talked about last week, because when we had the negative, so say it was negative 1/2, that meant negative 1 over a positive 2, or 1 over the negative 2, because the first one means to go down 1 and right 2. This one is up 1 and left 2. So you have all of these different options, but you have to remember I can go up, but you have to do what is said or the exact opposite of that for your slope. All right. So how about example 4? I'm going to erase some extra stuff here so it doesn't look so crowded for you.
Okay, I understand that now better.
Okay.
Because I just didn't get that part. Like, because I only thought we were graphing like 1/2 and 4. I was like, this doesn't seem right.
Okay. And to graph a line, you always have to have at least 3 points. Okay, like in this
I don't know
case.
where you're getting the third dot. So I understand it better.
Fair enough. Okay, so let's look at example 4. It says write 2x plus 3y equals negative 3 as a linear function, then graph the function. Okay, so is it in slope-intercept form?
No, it's not.
No, it's not. So the only way we can do that is to get it in slope-intercept form. Okay, what does it mean with like the y equal or function form?
Y equals mx plus b, right?
Yep. Okay, so when it says linear function, instead of using y, that's saying use that f of x notation, but it's the same thing as y equals mx plus b. We would just say f of x equals mx plus b. Okay, so let's work on that first, since it's not in slope-intercept form. All right, what will we do first? Chase, what's the first thing you do?
I would probably find the slope intercept.
Yes, that's what we just said. So how would you do that? You're okay.
So b is the slope intercept, y equals mx plus b. It's just the equation, but like flipped backwards. Like we could maybe rearrange the equation.
That's what we're working on. So how would we do that?
Let's move the negative 3 steps to doing it, but I think I know like what it would look like at the end.
Isn't the
Subtract 3
Not, but that's the thing. You need the steps.
isn't the 3 the B?
The -3 currently looks like the B. Yeah, because it's that constant. Mm-hmm.
So we need to do minus 2x.
Minus 2x. Yeah, we can move. The simplest thing is going to be to move the quantity with x to the right. So then we're left with 3y equals.
Y equals -2x.
We want the -2x first. Good.
Minus 3.
-3. Perfect. Yes, very nice. Okay, so we have it in that right form. We have the x coming before the b.
And then your m is 2.
Nope, we're not done yet because we have a 3y. We have to get it down to a single y. Abigail, how would we get y by itself? Divide by 3. Okay, so we've got to divide by 3 first. Then we have y equals.
-2x.
Not negative 2.
-2/3.
Nice. So we got -2/3 x minus 1. Excellent. Okay.
Does it have to be a plus?
No, it doesn't have to be a plus. Because the formula says it's a positive, but if you have a negative, like if you have -1, then your b is -1. Good call. All right. So when it says function form, we would just write this as f of x equals -2/3 x minus 1. That's just that little detail. Doesn't matter. But in order to graph it, we still need to pick those things out. So Bailey Malin, what's our slope this time?
Is it 2? I don't know.
Okay, so we can look at either of these two equations. You're good.
Oh, is it -2/3?
Yes, it is. See, you do know. So our slope is -2/3. And Cheyenne, what's our y-intercept? It'd be -1. Excellent. Okay. Abigail, come start graphing it. And then Olivia, I want you to come put another point up. That's your x-axis, not your y-axis. Good? Okay, nice. So you just went on the y-axis, down to -1, put your first point. All right, let's see. And then Bailey Malin, let's have you graph a second point after she graphs one for us. So -2/3. So there you go, down 2. Right 3. Perfect. All right, so Bailey Malin, you're up.
So could it go up 2 and over 3?
Up 2 and over 3, left or right? You definitely can. Yep, you can go up 2.
Up 2, so 1, 2, and over 3.
Left 3, you got it. Perfect. And can you go ahead and connect those for us?
Yeah, it's not even.
It's good. It's harder to write on than it looks. Excellent. And put arrows on both ends.
Can I go back?
No, you're fine. It's good enough. Put arrows on both ends and we're good. I was like, it's harder to write on than it looks. Excellent work.
Good job, baby.
All right, how do we feel?
Actually, it's really bad.
Actually really bad, like you don't feel well, or you feel really bad about math?
Oh, I don't feel well.
Okay, just checking. All right, so you guys have done fantastic.
We have?
Yeah, like that's slope and graphing from slope. Like you now can get an equation into slope-intercept form. You can pick out the slope, you can pick out the y-intercept, and you can graph it.
I never thought I'd be doing that.
Well, you'll probably get to do it a lot. It's like you guys were quite impressive. All right, so let's look at this real-world problem here. So an online company produces photo albums from uploaded photo files. If Sarah chooses to pay a membership fee of $25, a premium photo album will cost her $1.25 per page with free shipping. Write a linear function rule for the cost and graph the function. Then determine how much it would cost Sarah for a membership and a 23-page photo album. I know this sounds like a lot. Let me move this up a little bit more. But it's totally doable.
Sure.
Yep, I am. So we have to write a linear function rule.
Ugh.
So is that like the f of x thing?
Yes, or you can use f of x would be that. Or in this case, we could say cost, like cost per number of pages or something, but it doesn't matter. Okay, now, with that being the case, it's a linear function. This is a huge clue that it's going to be set up in a line. And an equation for a line is y equals mx plus b.
Yep.
Right? Like, that's what a line is. This is not a quadratic function. It's a linear function. That's a line. It's y equals mx plus b. All right, so that's super helpful. Because, so I'm going to write that up here. Y equals mx plus b. That's just to keep in the back of our mind. Now, it says there's a membership fee of $25. How many times does she pay that? Once. Okay.
Oh, that's cheap.
And a premium photo album will cost her $1.25 per page. How many times does she have to pay $1.25?
Per page.
Per page, for every page. So which of these numbers goes with is the MX?
The $1.25 page.
Yeah, the $1.25 per page, because this has to be per page. We're gonna have to pay this for every page. So that's $1.25 X plus what's the one-time fee?
25.
25. And so we use linear function notation, if you will.
Oh,
That is it. That's your equation.
wow, that's really easy.
That is really easy.
Psych.
Okay, so that's your linear function that we just wrote. Our linear function rule. Okay, then we're supposed to graph it. Okay, so where am I going to put my first point on the graph?
At 25.
At 25. Okay. And that slope of 1.25 kind of stinks. Okay. So how could we change that where we could graph it a little bit easier? Because these go by. We could change it to a fraction. What would that be as a fraction? 5/4. Okay. Okay, so that would be, all right, equals 5/4 x plus 25. That works. So how are we going to graph that? Because this graph's a little weird in this case.
So we go up 5.
Would we though?
Or
Because if we go up 5, that would put us at 29.
well, would you go like up like 5 in the pages?
5 in the pages. So that's all I'm saying is like I want you to notice, and that's it, that this graph does not go up by ones every time. And then the y side, the y-axis goes up by tens. The x-axis goes up by fives. So even that isn't helpful. So is there a way that you could do this that would be better? Like,
Not really.
because see,
That we're just gonna have to get over that.
we're just going to have to get over that. Okay, well, how are you going to get over it and do it? What do you think?
Practice.
Because remember, it's the rise over the run. So can we write an equivalent fraction to 5/4 that has a run that would go with one of these numbers?
Yeah, probably.
Yeah, like what's 5/4 equal to?
Uh,
Which one of these could we make it equal to make the 4 equal to? 5, 10, 15, 20, 25, 30. What?
20.
The 20. Okay, so we could write an equivalent fraction. So then it would be 25 over 20. So if we went to, we would rise 25, and then we would go over to the 20. So if we're at 25 now, what's going up 25 more? 50, and then we'd go over to 50 and 20.
That dog really.
Okay, so and technically we do only need 2 to make a graph. That's not a straight line. Okay, so it's a little harder to do when it's down here. All right. And there's only the one arrow on it because we have to have that membership fee. Okay. This one is a lot harder than like you have to apply a little bit more thinking, critical thinking to it, but definitely doable.
Have to do that with all word problems.
You kind of have to do that with all world problems. You got it. Okay, so then we graph the function. Okay, so that part's done. It says then determine how much it would cost Sarah for a membership and a 23-page photo album. So how are we going to do that one?
I would never pay this kind of money for a photo album.
Well,
How much would it cost for a 23-page photo album?
25 plus.
1.25 times 20.
Yes, because remember we said the $1.25 per page was our X. So our bless you
Really like
function of a 23-page photo album is equal to 1.25 times 23 plus 25. Or if you used y equals, it's the same thing. Right? You could also write this as y equals 1.25 times 23 plus 25. Okay, 1.25, so $1.25 times 23 is $28.75. So what is $28.75 plus $25? $53.75. Good. So our function of 23, which just means that if we bought a 23-page photo album,
$53.
it would cost $53.
All that for that.
It'd be like right about there.
Oh, obviously.
It's a photo book. It's a photo album.
Guys, this one's fake. It's not real.
Maybe it's a hard
I could buy
cover.
a 50-pound bag of 35-pound bag of dog food.
You can buy a lot of dog food, but have you ever bought a photo album online?
No, because I just use it on the iCloud. My mom
Okay.
does that.
But yeah, so photo albums can be pretty expensive.
My grandparents get us one every year.
Yeah, my aunt.
But here's the thing.
My aunt who takes all the photos gets us a calendar from Walmart.
In this case, she's paying for the membership and the photo album. If she prints, like say she's a photographer and she makes photo albums for people for their weddings,
Right.
she pays $23 one time.
Well, I mean, she's going to be earning all that money back.
And then she'd be earning,
She's going to get paid for it.
Yeah. But I mean, if she could make a photo album for somebody for their wedding for $53.75, and she probably charges more than that when she gets paid for that photo album. People pay big money for their photo albums from like a wedding.
My mom paid
like
Mhm.
this for this fall and this Christmas. My mom paid $300 for a 15-minute photo session. That's
Mhm.
a waste of money.
Yeah, that's
Mhm.
a lot.
It is. All right, then you are ready to get started on your homework.